Good morning. Welcome to science class. Today we're going to continue our lessons on energy, and our focus today will be all about temperature. Okay. Just to do a quick recap, well, before we get started, this part 1 video will be just running through just a few PPT slides, and then we will read the textbook pages, and the part 2 video will be going over the workbook. So, just a quick recap. We talked about energy. Energy is everywhere. There are different kinds of energy: electrical, sound, light, mechanical, chemical, which is how our body digests food. We learned that energy can change to other forms, such as a flashlight. If you put batteries inside a flashlight, it changes from a chemical energy to an electrical energy. We learned that. We learned about potential energy and kinetic energy. If you remember our roller coaster example, potential energy, it's not moving. It has the potential to have energy, right? And then once the roller coaster goes down, it is kinetic energy. It's moving, motion. Some other examples here. We learned about thermal energy, which is the total kinetic energy of the particles in a substance. In other words, the hotter the temperature and the bigger the mass, the more thermal energy it has. So we talked about the hot cup of water versus a cold cup of water. The hot cup of water has more thermal energy. Okay, so that was a very quick review. We're gonna just do a quick learn a couple of things about temperature. So temperature, think about all the particles in a substance. Temperature is the speed, the average speed on how those particles are moving. Because not all the particles move at the same speed. Some might move faster, like here. You can imagine the vibrations, that it's very close to each other. It will move really quickly, and then some will move slower, a little more chill. So temperature, the average speed. I know we usually say like, oh, what's the temperature today? We might say, oh, it's hot today, it's cold today. Scientists don't really like to use those general terms. They want to have the exact temperature, obviously, because when you do science experiments, etc., it's good to know the exact measurements. So every time we say something's hot or something's cold, we're actually talking about how fast the particles are moving, the average speed of the particles. The difference between temperature and thermal energy is that, well, temperature is just the speed. How quickly are these particles moving? If something has a greater mass, so for example, this beaker has a lot more water than this cup, then it will have more thermal energy. We talked about that. But if the average speed of the particles in the water is slow, then the water might feel cold. So in other words, temperature is the average speed. And thermometers are the instruments that we use to measure temperature. We've seen these, right? And there are a couple of units that we use to measure temperature. We have Fahrenheit, which is what they use in the United States. I believe the rest of the world uses Celsius. Korea uses Celsius. So you can see kind of the difference here. We also have a Kelvin scale. That's something that scientists use as well, and the book will give us more details about it. So shall we read? So we're at page 88. We're going to be just reading 2 pages because it's a lot of details and information. So again, if you would rather read alone, that's totally okay. You can just stop this video here, read on your own, and complete page 62. And then watch the part 2 video to go over the answers. Otherwise, I will start reading. Temperature. When we talk about temperature, we usually mean how hot or cold something feels to us. On a summer day, you may feel hot. On a winter day, you may feel cold. Sometimes, even in the same conditions, one person may feel comfortable, another may feel cold, and still another may feel warm. This is very true, right? Like in our classroom, some of you guys always ask me to turn on the AC, and some of you guys say you're cold, some of you guys say it's hot, etc. That's why hot and cold are words that we use to describe how we feel, but they're not very accurate or useful for science experiments. So scientists need terms or words that have more exact meanings. One word scientists use in an exact way is temperature. Temperature is the measure of the average kinetic energy of the particles in a substance. Particles are always moving. However, not all the particles in a substance move at the same speed. Some move faster than average and others move slower. So finding the average speed is more accurate than saying how hot or cold a substance feels. Temperature is not the same as thermal energy. A substance with great mass has a lot of thermal energy. However, the average speed of its particles may be slow. The substance may still feel cold. In this case, it has a lot of thermal energy because of the great mass, but a low temperature because the speed of the particles is slow. Kind of confusing, I know, but hang with me. How can temperature be measured exactly though? God designed your body to adjust to different temperatures. For this reason, you cannot measure temperature by how something feels. If you go swimming in a pool, the water may feel cold at first, but after a while, the water no longer feels cold to you. The water has not gotten warmer, it's just that your body has adjusted to it. So to get an accurate measurement of temperature, an instrument that does not adapt to its surroundings must be used. So a thermometer is an instrument that measures temperature. This is a thermometer. One type of thermometer is made of a glass tube containing red-colored alcohol. So again, right here, this is what they're talking about. Numbered markings on the tube allow you to measure temperature in units of degrees. You have probably had your temperature taken with a digital thermometer. The temperature shows as a number on a small screen. So a digital thermometer is something like this. Gives you the number. Temperature is usually measured in degrees Fahrenheit or degrees Celsius. Some people use the Fahrenheit scale. The nurse probably takes your temperature using the Fahrenheit scale in the United States. The weatherman usually tells the temperature outside using this scale. On the Fahrenheit scale, water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. Scientists, however, usually use the Celsius scale to measure temperature. We also use the Celsius in most parts of the world. The Celsius scale is based on the freezing point and boiling point of water. So on the Celsius scale, water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. All right, so a little more information about Kelvin. That is another type of way to measure temperature. Let's read about Lord Kelvin. Fahrenheit and Celsius are not the only scales used to measure temperature. The Kelvin scale was developed by William Thomson. Born in 1824 in Belfast, Ireland, Thomson studied thermodynamics, the science of heat and energy. His temperature scale is based on the movement of molecules. Instead of degrees, his scale uses kelvins. He placed 0 at the point where he believed that molecules no longer move or have kinetic energy. Absolute 0, written at 0K on his scale, is equal to about negative 273 degrees Celsius. Thomson also had a great impact on communication technology. His inventions allowed the first telegraph cable to be laid across the Atlantic. In 1866, he was knighted by Queen Victoria of England. Later, his title became Lord Kelvin. Although Lord Kelvin was a highly honored scientist, he was also a humble Christian. He said, if you think strongly enough, you will be forced by science to the belief in God. He continued to study science until his death in 1907. Fabulous. All right, so go ahead and complete workbook page 62. You're going to be looking at the pages we read on Tuesday and today to answer the questions. This one is basically you're going to say if it's kinetic or potential. In here are a little bit more factual questions, okay? So once you're done with that, play part 2 and we'll go over the answers. Bye!